Okay, today's lesson will be about both axial symmetry and central symmetry. But first I'll go through axial symmetry for you. This is a transformation where each point on the plane maps another point also on another plane so that the axis will be perpendicular bisectors of the segment. Now out of this lesson I want you to, there'll be three learning intentions. I want you to be able to identify an axial symmetry in a question, understand the properties and principles of it, and be able to answer a question on axial symmetry. So if we go to the computer here, I'll show you a video on axial symmetry. As you can see, the shape has been transferred over onto this side of the axis there. You can see this, the distance from here to here would be the same from here to there, and from there to there, from there to there. And I've done this out on a sheet right in front of us. You can see I drew this triangle ABC with angle X. I measured using my compass, put my compass point there on the axis line, extended out to B, and swung it over to the opposite side so that it's the same. Distance. For C, I could also have used my compass, but as you can tell, if I bring this line straight down and that straight across, it'll give me C. But of course, for A now, I will have to use my compass again to extend it out to there and bring it back over this side for A. And when I join it all up, it should be the exact same triangle with the exact same angle X. So I'll just go through that now in more detail on a template here. So once again, we'll just use just go for a triangle. We'll make an equilateral triangle, so we'll make all sides the same. Make it 400. I just need to go back there, sort out this dimension, just to make it like that. Now, so once we have that, I'll just hide these first. Now that I have my shape, my triangle, we'll label A, B and C. I'll draw my axis. This is what it has to be transferred across. There's my axis, and once again, now obviously I don't have a compass on SolidWorks, so I'll just, on the top point here, just draw a line across any distance, and this is where you'll have to, this is where you need to focus. Again, smart to mention, measure the distance from the top point to your axis. It's 366, that's perfect. So I'm going to put a point on this axis here. You can just put it anywhere for now. And smart to mention that, so that it is 366 millimeters away. Perfect. So now that point here, B, is the exact same for B1 over here. Now I'm going to do the exact same for the two ground points here, A and C. Now they'll both be on the same line, so it'll be very easy to demonstrate. 2 points again randomly, and smart to mention them. Get point A, measure the distance to the axis. It's 566, so we'll measure the distance. Now this is A here. A lot of people would think A is this point, but it's actually the furthest away point, as you can tell. And it's 566. And do this for C. It's 166, perfect, yeah. So measure this distance from here to here and make it, it's actually 166 already, which is perfect. So now all I have to do is draw the outline of my shape. And now this shape is the exact same as that shape. It's the same size. All angles inside it should be the same. I'll just show you. 60 degrees, yeah, for an equilateral triangle, perfect. And we'll just do that again, just to show, yeah, 60 degrees, so all angles are the same. It's just a different orientation. Point A here is all the way over here, B is up there, and C is here. Each point is moved equally across the axis, and that is axial symmetry. So now I'm going to go through central symmetry for you. This is a transformation where a point within an object through which any straight line passes through 2 points on the edge of the figure at the same distance from the centre point but on opposite sides of the point. So it's also another transformation. The learning intentions are the exact same as axial symmetry. I want you to be able to identify what central symmetry is, understand its properties and principles, and be able to answer a question on central symmetry. So once again I'm going to show you a video of central symmetry. All points are going through this exact same point. If I just go back there for a second, as you can see, all points are going through the exact same point, and they are measured putting your compass here, extending it out to B, and flipping it over so you get B. And I've that once again done on a sheet in front of me. So I went for a simple triangle. With your point here, you brought all lines through the point, any distance. Again, you won't know the distance until you measure it. Got my compass, put the point of it on your sensor, extended it out to B, and swung it the other side for the image. Once again, it will be the exact same shape, exact same size, same angles within the triangle. It's just a different orientations, and each point will move equally through the point. So I'll just quickly show you now how to do this on central symmetry again. So once again, I'll just go for a triangle. That didn't go well for me. Go for another triangle. I won't bother dimensioning it. It doesn't really have to be dimensioned. It'll work out the same size. I can put my point anywhere. Doesn't really matter. I'll just leave it there. And once again, drawing a line from A through my point here. Just making sure that it's going through it. Zoom in if you need that, just to make sure that it goes through. Perfect. And I'll do that for points B and C also. Again, I'm just making sure that my point is that my lines are going through the point, because that's if they don't go through, then I won't have the correct shape, the exact same shape. Sorry. So once again, go to Smart Dimension, measure the distance from my point A here with my center point, and it is 773. Perfect. So draw my point, put it on my line here, and this line has to be 773 millimeters away. Perfect. So now that is A1 for my image. Once again, I'll do the exact same for point B here of my object. It is 813. Perfect. So put my point. Make sure I put my point on my correct line, so it's this line here. Make it 813. Just on my page, lucky. And then for my last one, once again, draw my point, which is C here, on this line here. Measure the distance from here to my center point. It is 425, so measure that now. From the point here to here, make it 425. Now I've got all my points for my object, for my image, the image of the object, so now I just have to join them together. Here, 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 and here is the image of my object by doing central symmetry.